Hello, in this presentation I'll be looking at the pyramids of Egypt, so not just the pyramids of Giza but also the Meidum Pyramid, the Red Pyramid and the Bent Pyramid, and how they connect through sacred geometry. I'll be doing some geometry instructionals with compass and straight edge along the way, and also showing how they connect to the Quadrivium or Pythagorean schools of thinking, Hermeticism. I have posted these individually in the past, but I did make a slight error in regards to the exact slope angle of a pyramid, which I repeated across a few of these videos. So I want to correct that as well, but also just for convenience to put them all together. I hope you enjoy. Please watch through. Feel free to share, comment, like as you want, and thank you. Okay, so with some very simple geometry, the same links will be in the description to previous episodes in this little series. The basic geometry, sacred geometry, the Vesica Pisces and how it applies. We've already shown the the Red Pyramid, how that connects to Khafre's pyramid, how that connects to the Great Pyramid through the 2:3 ratio, which also incorporates the 3-4-5 triangle of the Pythagorean theorem, a squared plus b squared equals c squared. But now we're going to do another construction, again based off the Vesica, and we'll be able to use that to once again connect the Great Pyramid to the Red Pyramid as well as to the Bent Pyramid. And as always, we'll begin with construction line. This is a very simple construction, but it just involves a little bit more. And so start with a construction line, and then we'll draw the Vesica, the vessel of the fish. So one circle, second circle with its center on the edge of the first, and there we have our Vesica. Now what we need to do is again this construction line between this point and this point. And I'll try and keep the colours mixed up so that the lines don't all lead together. And here now, we haven't changed this compass. I'm going to be using two compasses because I want to keep this one at this length, and then we're going to use this. You could of course use the same one, but this compass will not change. Okay, and so now still the same size. Now we've got that center point, and what I'm going to do is mark that there. Now what we have, okay, I'll draw it anyway, and I'll draw it in a few separate sheets so it doesn't mess up, but just as an idea. So now we have this triangle here. Okay, this is a very simple but important triangle because it's basically going to lead us to the golden number, or phi. So we have the compass setting, the radius of the circle, and there we have that there. So that would be r, or the radius. This is half radius, so we're going to call this 1. So that edge is 1, therefore that is 2. Therefore this is the square root of 5, and we can prove that because Pythagorean theorem, as is encoded in the other pyramids, a squared plus b squared equals c squared. So if this is a 1 squared plus 2 squared equals, well, 1 squared plus 2 squared is 4, so that equals 5, but we need to find the square root of that. So that's, therefore, that is the square root of 5. Now the golden number, or phi, is equal to the square root of 5 plus 1 over 2. Okay, so pause for, okay, now I'm going to, okay, I'll show you the construction and I'll start on a fresh piece of paper. Now what we need to do is set this compass to that square root of 5 length. You don't have to draw, but we can just we didn't really need to do the mark, I've drawn the arc there. So that's the square root of 5. We've added the square root of 5. Therefore, this length is the square root of 5 plus 1 is this length here, and therefore that is 2. Therefore, this length, we can now call that 1, and the ratio of 1 to this length will make that phi, the golden number, the golden ratio. So we have a phi ruler to begin with, which is, there's been, what do they call it, hermetic triangle, but so what we have is the golden ratio. This in itself is important to the Great Pyramid. So for instance, okay, I've probably messed it up too much to make it clear, but okay, I'll have to do it on a fresh piece. So let me pause it. Okay, so we'll just repeat that construction just to show, because we're going to draw the Great Pyramid is basically in that pattern, in that construction. So once again, the Vesica, and we draw a construction line, so that's 90, 90, 90 degrees. It's a good template for, it's a good way, you know, on any blank piece of paper to get a good drawing template going on. Now, without changing the compass there on the center, we mark that. I haven't changed that length. That length is the square root of 5, so this would be 1. That's the square root of 5. If I mark, I'll draw the arc to show you, just to keep it clear where it comes from. And already showed, so this would be 2, and that would be phi. Now, what we want to do now is, so if that's, okay, so as a proportion, that's 1 to 5. But here, if we're defining that as 2, that would be 2 to, and this length would be phi times 2. So what I want to do now is, I'm going to draw a, we can do that easier. So I want to put the, again, this is the original setting of the compass, and now on the outside there I'm going to draw another circle, and now with our compass here on the center, we draw another circle. So what I've really done is, we're still using this length here, that would, and what I've done by drawing this circle and this circle is I've bisected this. What I've done is cut this yellow portion in half, which was phi times 2. So by cutting it in half, okay, so we have just a, if this one here is 1, therefore this portion, I'll choose it different. Okay, so therefore this portion is phi, or 1.618033 transcendental onto infinity. So what we now have is a phi ratio with that. So what we can now do, we know the proportions of the Great Pyramid, so I'll mark that. Okay, so now we have our phi setting, but so let's, if this now, we're going to use that as the base of the Great Pyramid. I'll change this compass, and we put that setting to phi. Therefore, put this now on the edge there. If if I mark it here, and I'll do it on the other side, it's not necessary. What we now have is the Great Pyramid. I've stated that in black. I'll just freehand it. Because if this is 1, therefore you set the compass to phi. There we have the slope of the Great Pyramid, which is at a ratio of phi to the half base. So now we have the Great Pyramid at 1 to phi. Using the official measurements, not the official, sorry, the idealized measurements of 440 base, 280 height, that proportion
1.61859.
However, using the actual measurements such as those of J.H. Cole and Matthew Flinders Petrie, if this is 1, then the slope angle would be phi, 1.618039. Now I'll put some graphics there just to show what I mean by that. So with this construction where we've started, where we get this phi ratio, we can draw a Great Pyramid. I'll also put a link in the description to how you can make, using this technique, this, just out of paper, how to make a three-dimensional model of the Great Pyramid. It doesn't include these flaps, or sort of, you have to, but anyway, what we have is this phi ratio that's built, the phi and pi ratio, which is built into the pyramid and the slope angle. Okay, but that will, the link to this video will be in the description. I'll put the links to a similar video with this in the description. I've tested this on GeoGebra, and this is 100% accurate, but I'll get to it. There's a few more. So this is a Great Pyramid, and the importance of the phi ratio, and of course the pi and phi ratios built into the pyramid. And that will connect us to the bent pyramid and the red pyramid.
Hello, this will be part 2 in the series Sacred Geometry of the Great to the Bent Pyramid. And here we see the famous pyramids of Giza, the Khafre's pyramid on the left and the Great Pyramid on the right. That's the most famous. Khafre's pyramid is often confused with the Great Pyramid next, underneath the Sphinx there. But the red pyramid and the bent pyramid are also connected to these through geometry. Link to part 1 in description. And there's a very beautiful, a very simple underlying geometry which describes the main proportions of these structures. They're very complex, so there's a lot more to it, but the main dimensions and the main proportions emerge here from the Vesica. So we've drawn the Vesica Pisces, this important fundamental construction of what is termed sacred geometry. You could apply Euclidean geometry if you don't like the word sacred. It's not really important. What is important is the measurable connections between these pyramids and the what has to be a underlying geometry of them, at least in my opinion. Call it coincidence, I think that's really stretching it. But so here we are looking towards the Great Pyramids now. They're off there in the distance. We're looking north, and so the Great Pyramid, Khafre's pyramid, and the smaller Menkaure pyramid is here. But what we have is the bent pyramid and the red pyramid. These lesser known, not too much studied. The focus tends to be on the Great Pyramid, and I think that's deserving because of the pyramids. It's just spectacular. The math, the astronomy, well, the geometry and the connections between them. But with the Quadrivium, music, geometry, astronomy, and arithmetic. Just to give an idea, so there we have the 3 pyramids of the famous Giza pyramids on the Giza plateau there, just outside of Cairo. Because of the angle, Menkaure's pyramid is quite a bit smaller in comparison. Khafre's pyramid, it's easy to identify. It's the one that still has the casing stones on the top, and it appears to be higher, and at the moment it is, because, well, the Great Pyramid has lost some of its stone at the top, but also this one in the middle, Khafre's Pyramid, is built on a platform 33 feet higher than the Great Pyramid. That's an important feature, 33 feet, which is repeated elsewhere in that Khafre's Pyramid complex. But the Great Pyramid is the largest of the pyramids. Now, we also have the Red Pyramid, and we also have the Bent Pyramid, and these are all connected, and we'll see that in a moment. But so, for clear view now, to begin with, just to recap earlier episode and features. So now we have the Vesica, which is this 3:2 ratio, which is so important in music, for instance, a perfect fifth, Pythagorean schools of knowledge, and we'll see that in a moment as well. But the base of the Red Pyramid at 420, and the height of the Great Pyramid at 280 Egyptian royal cubits, ERC, just for reference, Egyptian royal cubits, creates, as we see, a 3:2 ratio. Now what's interesting is that the Khafre's Pyramid, the base to the height, is at a 3:2 ratio as well. So we start to see some of, well, these connections that join in there. And we're going to get to the Bent Pyramid towards the end of it, but just as a recap of the earlier episodes. And, well, Khafre's Pyramid and the Great Pyramid are also joined through the Vesica, but more specifically through the 3-4-5 triangle, or Pythagorean theorem, a squared plus b squared equals c squared. The 3-4-5 triangle is the first of the Pythagorean triplets, or the whole number, so the next one's the 5, 12, 13, but 3 squared plus 4 squared equals 5 squared, a squared plus b squared. This is a beautiful piece of knowledge, because once you understand this ratio that exists between triangles, you can really work out so much. It's one of the cornerstones of geometry, and of course will connect through arithmetic. But Khafre's Pyramid, the Great Pyramid, and the Egyptian rope stretches. Now this was how they used to measure land, especially like after the flood. If a portion of land was lost, this creates a 90-degree rectangle, and that was used to adjust taxes. For instance, if you lost some land to the river, your taxes would be adjusted. And it's still amongst the establishment that the Egyptians didn't really understand pi, that they didn't understand phi, and that they didn't understand the implications of Pythagorean theorem. It's said that they only understood the 3-4-5 triangle because it creates a right angle. And I think, well, it really doesn't hold up, because the Great Pyramid is also connected through the 3-4-5 triangle, the upper chamber, or the king's chamber, which is made of granite, unlike the queen's chamber or the lower chamber, which is of limestone. That's not made of limestone. Sorry, the queen's chamber is not made of granite. That's a limestone chamber. Granite is only used in some portions. This very special granite is only used in some portions of the pyramid. The grand galleries, a few smaller connecting sections, and the upper chamber. That's what makes these, the upper chamber and the grand gallery, so special, because of the maths and the geometry involved in there as well. But we see a connection here. So from the 2:3 ratio, we get the 3-4-5 triangle, which also brings us to the Great Pyramid, and the Vesica Pisces, the vessel of the fish. So we'll draw on more and more lines, more connections. A lot of this is already being published, usually in separate pieces, but we'll start to draw more and more connections, and really have to question the establishment view on these things. So these, in this sort of smaller series, the sacred geometry of the Great Pyramid, Khafre's Pyramid, Red Pyramid, and Bent Pyramid, from the Vesica, from these very important, such as the 3-4-5 triangle, the Pythagorean 3-4-5 triangle, Pythagorean music, which comes from the 2:3 ratio, the perfect fifth, 2:3. And again, these will be connections, but will be just as a recap, and we'll be looking at the how the Bent Pyramid, the Red Pyramid, and the Great Pyramid connect especially through phi and especially through the pentagram and the pentagon, which is a perfect geometric representation of phi, or the divine proportion, the golden number, this ever so important constant in not just on Earth, but as we'll see, on a much wider scale.
Okay, so the Great Pyramid, the phi ratio and that construction, how does it connect to the bent pyramids? To the bent pyramid and the red pyramid. So begin with the construction line, again starting with the Vesica. Make sure they're all in shot, yep. Another line down there to give us 90-degree angles. I'll also, yep, and so with that now we place our compass point there on the centre. You draw that mark. So that would be, if this is 1, this would be the square root of 5. Pythagorean Theorem, again that's incorporated in Khafre's pyramid and the Great Pyramid, the 3, 4, 5 rope stretches of ancient Egypt. Okay, so now we have that marked. Again, we haven't changed this compass setting. You put that in the centre. So, okay, I actually should have included that in the original construction, this third circle. And now we'll draw that same circle. We haven't changed the settings. And again, links will be in the description where I go through the math of it to show it, because there's a lot of beautiful stuff. This is a perfect phi gauge, phi squared, whole bunch of really important stuff. We have the for instance, you see the 30, 90, 60, 30 set square going on in there. We could also do the same with the 45, 45, using that point and this central circle, this one here. So what you have is your set squares. You also have this square root of 5 set square, which isn't included in the normal drawing kit, but should be because it's so important to phi. Okay, but now what we're going to do is we're going to draw a perfect pentagram. Again, I've checked this in GeoGebra, and well, actually what we have here is all the pieces to draw a perfect pentagram. And what we really need to start with is this point, this one, the centre, and this point here. And with those we have everything we need to draw the pentagram. And so firstly we'll line up those, do the same on the other side. Again, I've checked this in GeoGebra, it is perfect. Now when I draw it, the lines might not be exactly, because again I'm drawing it by hand and not being as accurate as I could be. Okay, now we need also to think about this point here, and so you do the same from here through there. And there we have a perfect pentagram, which is a perfect depiction of perfect geometry of the golden ratio 1.61803339, etc. So there we have it. There it can be in GeoGebra. I'll put some graphics there to show how each length compared to the other will bring us its perfect golden ratio, all based on the square root of 5 plus 1 over 2 proportions, as we saw in the beginning. So there we have a pentagram. we have the phi ratio, which is the basis of that, which also gives us a way to draw a great pyramid with the 1 to phi half base to slope proportions there. But how does it connect to the bent pyramid and the red pyramid? Well, firstly, the bent pyramid is a 6/5 ratio. So what we need to do is now draw a pentagon. So we're just going to connect those points up. Should be in black to separate it from the background. So we have a pentagon, a 5-sided face, and this geometry will, what we already have now is a definition of the slope angle of the red pyramid, as well as the top portion of the bent pyramid. So with a pentagon, okay, so what we have now is, firstly, the bent pyramid and the red pyramid are of the same height, so that's their first connection. They're both 200 royal cubits high. Now what we need to do is to find the center of this pentagon, and so we can, okay, so start with this. So when I go draw a lot, so from this point through here, we're going to do the same from this point through there. Again, I'm rushing this, so you want to, if you're doing it, you want as fine as a pencil as you can, and to do it as accurately as you can. And what we now have is the center of the pentagon. Now I'll do it one more time from this point through here. And if you draw it accurately and take your time, these lines, we'll see. So what we have there is the center of the pentagon. Now from that center, I'm going to, from the center to one of the points, from that center to one of the points, and now with this, what we have is a description of the unfolded. If we unfold the top of the bent pyramid, or if we unfold the red pyramid, this is what we would get the projection down.
In the top right we can see a SketchUp diagram from Secrets in Plain Sight by Scott Onstott. Link will be in the description. Fascinating series in regards to both modern and ancient architecture, symbolism, connections. But what we see is the unfolding of the bent pyramid, and it creates pentagons and hexagons, and more importantly the triangles which form the basis of those. And so yeah, again, that link will be in the description. A fascinating series, but this also has implications for the red pyramid as well, because they share the same angle. And next I've made some animations just to show exactly what I mean by that. And so now in the top right we have this unfolded pentagrams around a square, which forms the base of, well, the base of the red pyramid, or the base of the top section of the bent pyramid. So here we see that diagram again, and now we can have a look and see exactly how this pentagon, this pentagram, and the defining angle from the center goes on to describe both the bent and the red pyramid, and that of course will connect it to the Great Pyramid, which also connects to Khafre's pyramid and back to the Great Pyramid. It all blends in together, but as you see, just by folding up those angles we start to create this pyramid shape, which is the bent and the red pyramid. Again, this is just really that these particular angles were chosen is just really so important, and really does confront the existing version of history, which will say that this was basically an accident, but it's an extraordinary set of coincidence. And I say that very, very sarcastically, because these are the perfect angles to create these shapes, and it goes on, and we'll look at it even more, but this is just the beginning, because there's more extensions, especially over to the Platonic solids, and so much so much other very important geometric information. So as we've seen, if we create a square surrounded by these pentagrams, pentagons, and we fold this section up, this is the shape that we get. Now that angle is of 43.22 degrees. Some details in there, but let's, for example, the slope angle of the red pyramid is 43.22 degrees. Now if you do again Wikipedia search, which unfortunately tends to be the standard, you'll find that it'll vary slightly, but there are several sources. I'll put a link in the description, more professional sites, let's call them, that have the slope angle of the red pyramid at 43.22 degrees. Now, of course, anything to do with measure, especially with these ancient sites where we've lost the casing stones, there's always going to be a question mark around that. But if, for example, as we shall see, on top of the surveys that's already been done, is some very important evidence which will show that this seems to be, well, would have to be the more credible angle, because this angle, as is on the slope angle of the red pyramid also. Now it's, I mentioned the link to Scott Onstott, amazing series, Secrets in Plain Sight. Again, highly recommend it. Link to that will be in the description, because that was where I first heard about the bent pyramid. Now I can't remember the name of the original researcher who come up with that, but yes, Secrets in Plain Sight by Scott Onstott, must view, a compilation of many researchers plus the research that Scott Onstott has done himself. This 43.22 degree angle of the red pyramid, that's where I found out about the bent pyramid, so this top section. Now there's a whole debate, and I won't go into it too much, but there's basically a few explanations why the bent pyramid occurred this way. Some say to save time, some say they were worried about a collapse. Well, what we do have is some beautiful geometry, and I'll explore that more in the next section, because it's not only pointing to the pentagram and pentagon, there's also some very lovely connections to the Platonic solids here. So if it was a change in design because they were worried about the structure's strength, or because they wanted to finish it quickly, well, in another extraordinary symphony of coincidence in regards to the pyramids of Egypt, they happened to do it, accidentally create just the most beautiful series of connections as well. So just like the meter, the cubit, the second, so much information in the Great Pyramids and others such as the Vesica, well, just by accident again, they happened to build it to a certain height and then change the angle, which is extraordinary. And so same angle on the red and the bent pyramid, pointing to this pentagram, pentagon design, which is of course very important in fire. So both the red and the bent pyramid, which are very close to one another and to the south of the Giza plateaus, have possible connections there. Well, they happen to have encode the same important angle. There we get an idea of where they are in relation to one another. And they just happen to be of the same height of 200 royal Egyptian royal cubits. This very important measure which connects the second, the meter, via the pendulum. And of course that angle of the pendulum, again, covered it in before. It's just an extraordinary set of coincidences. And this pentagram, or the pentagon angle, well, the pentagram and the pentagon not only is the number of degrees inside a beautiful connection, for instance, there we see 72 being this the heart angle, which creates these red triangles here, but also in trigonometry it brings us to the golden number, phi, 36, 72, 108, 36, 72, 108. These are the defining angles of the pentagon and pentagram, and even in proportion. So we can see this color code here, so how each line, each major section, each piece of the pentagon and the pentagram are at a perfect representation of the golden number, phi, once more. Just extraordinary. And of course this is, well, why is it so important? Why is this, why is this number so beautiful, so important? I must also say that there is no evidence that the Egyptians were using the 360-degree compass. We know that they had just like the Babylonians had a different way of doing trigonometry. All the evidence points to that they were using Vesica, which was a different way they were working on angles in proportions rather than the 360 degrees. However, the 360 days plus 5 days they were using, so we can't rule out that they had knowledge of the 360 degree compass, which is just so important in regards to precession, weights and measures. All these lovely harmonic numbers are just embedded in these things. But why is the golden number so important? Well, here's some small collection of examples in it. In arithmetic and so many other elements, it's just the most beautiful number. But on the micro to the macro, phi is a constant. It's like pi, and it's embedded throughout the Great Pyramid, but it's built into nature. And that they would have observed these, whether it's in flowers or horns or pine cones, cacti, just so many examples of it. It is a constant within nature, and it's just a lovely thing. And that's why it would be so important to encode this in these ancient structures, not just the pyramids. We also find it in ancient sacred temples across the world, across time, across cultures. There's a bit of hate amongst certain elements, but the fact is it is a proven, verified, bona fide thing. Whatever anyone says, that's ideologically speaking. Now, there is a confirmation bias on my behalf, but there are also some who would seek to deny this or minimize it, and that in itself is an example of denial on an extreme level. But this, of course, will also bring us back to the Great Pyramid. So both the red and the bent pyramid not only sharing the same height but the same angle in the top section of the bent pyramid and the throughout all of the red pyramid. And so you could shrink this down and drop it on top of the bent pyramid. You have the same thing, but they're of the same height as well. So that's another point of something very important, worth investigating in future episodes. The Great Pyramid, well, that's also connected to the golden number and 5 through so many other examples. I dropped a link in the description and showed earlier. The Great Pyramid resonates with the divine proportion, the golden number, phi. And there we see just one example of it. So the slope angle of a pyramid in relation to the half base is at phi to 1. Now again, there's some important points in regards to this. The links in the description will touch on it. I've done lots of videos on it, but again, it's we need to use the exact survey measures, not the ideal measures, which tends to have become normalized. But definitely not just in this aspect, but in so many others, the golden number is built into the Great Pyramid, and that of course connects to the red and the bent pyramid as well through this very beautiful, very significant geometry, compass and straight edge geometry, which is an important piece of nature from the macro to the micro. And so again, we just phi, pentagons, pentagrams, these lovely numbers. These are processional numbers as well. They're harmonic numbers, weights and measures throughout cultures, across time, still with us today. These numbers are just so important, and they're beautiful in arithmetic, They have applications in music tuning, in astronomy, and of course geometry. It all just comes back to one. It just all bleeds in together. And so just like that, this angle was chosen by accident, and just that the Great Pyramid angle was chosen by accident. Well, it's just an extraordinary symphony of coincidence. So they just happen to pick these measurements, these dimensions, these angles, just all come in together, and it really, I'm lost for words that that so many amongst the scholarly establishment will either diminish this, deny this, or try and mock this. This is measurable, tangible, and to say that this is a coincidence, or to use, it's just beyond words. It really is. Compared this amount of evidence to, especially the Old Kingdom, and to what's considered acceptable amongst so much of the establishment, is built on whispers and fractions of elements and missing pieces. But here we have a mathematical, geometric, the astronomical connections as well. This is tangible, it's measurable, and yet this is considered the fringe. This is considered the outside. No. This is empirical. So much of the accepted version of how and why the pyramids is built is really built on a house of cards. So there we see this is what's happening. This is the geometry. This is the beauty in this system, and it's not just about the Great Pyramid. It's not just about Khafre's. It also will connect to the Bent Pyramid as well as the Red Pyramid, and I'll draw some more connections because there is a lot more, and much of this is published, but more in sections. But as we bring them together and start looking at them, the other connections will emerge from this, and it just shows a coherent, connected system, which is just so important. These are not arbitrary angles. These are fundamentals, constants built into geometry, arithmetic, into nature itself, and extraordinary symphony of coincidence or engineered. Well, these buildings were engineered. They were not made by coincidence, and I think that enough on its own, this question is enough, not proof, but to challenge the accepted view using this evidence. I think is very, very important. We need to be as rigorous and use this type of information to break the establishment hold on this particular part of history. Hello, this will be part 3 in this particular series, the sacred geometry of the Great Pyramid through to the Bent Pyramid. And firstly, thanks to Khafre for allowing me to use his footage here of the Bent Pyramid. Very interesting, and again, big thank you. I'll put the link in the description also to a related one on the Red Pyramid, where he goes inside. It's just interesting with the casing stones and all the stones on the inside, and that's something else. But the focus, so previous episode I looked at, firstly we drew a pentagram relationship to phi, how these things connect to, well, across the pyramid, especially Khafre's pyramid, the Great Pyramid, and through to the Red and the Bent Pyramid. And I showed how the top section of the Bent Pyramid here is an unfolded pentagon. Well, now underneath it's hard to see, but we see hexagons, and the bottom section of the Bent Pyramid is a series of hexagons, or more specifically, it's a series of folded equilateral triangles, and that's a very important feature. Top left corner, we see I'll draw the seed of life. Now, if you extend this out and keep going and moving forward, you get the flower of life, and then the fruit of life, which is the pattern famously in the Osiron temple as well. And I'll try to remember Khafre visited that as well. Very famous there in Abydos. But the main feature will be, well, how do we draw? How do we construct? We've already done the top section. Well, we're going to do the bottom section and look at some deeper implications for it and really ask questions, because the official story says that the angle changed either because they feared a collapse or because they wanted to finish it earlier. Well, that would be an extraordinary coincidence that they just happened to incorporate this geometry at exactly that time that they shifted the angle, and the angle that they shifted to being the Pentagon or the Pentagram, and the base. When they began construction, they were using this angle which incorporates the equilateral triangle. If they had kept building the bent pyramid at the angle that they started, they would have created one half of an octahedron. That's those are for Platonic solids, and we'll examine that now. Beginning first with a recap of what we've done, and so we've drawn the pentagon, the pentagram, and the triangle which makes it up, and so we see 4 pentagons around there in the red section. How the heart, the triangle at the heart of this particular construction, connects to, especially the bent pyramid. It also connects to the red pyramid, but this the pentagon, or the 5-sided shape, will also connect us to the hexagon, or the 6-sided shape, in exactly the same manner. So now we see those 4 triangles, and what happens is, if we fold them up until they meet, what we do is we create the top section of the bent pyramid, or alternatively we create the entire pyramid, described the red pyramid as well. And the pentagon's not just just any old shape. It incorporates the golden number, the divine proportion, over and over again. In terms of the divine proportion, it is the most perfect shape description of it. Therefore, both the red and the bent pyramid are incorporating 5, a golden number, just like the Great Pyramid is. The Great Pyramid resonates with it, not just in proportion, but also through the measures which define it both inside and out. So again, if the bent pyramid, the top angle was a mistake, and throughout the Great Pyramid those proportions were a mistake, and that the measurements within the Great Pyramid were also a mistake, surely it's one of the most amazing coherent symphony of mistakes, a symphony of coincidence, if you want to call it that. But it's clearly not. These were, each of these pyramids were designed with exquisite. The construction of them, it's an amazing feature, and that to call it coincidence, or it really is pushing it beyond any beyond reason. And unfortunately, the Zoe Hawass teams will call this pyramidiots, people who pursue these types of things. Clearly, they're trying to protect something, or they're incompetent when it comes to the beauty of geometry and maths, and how it's a underlying cosmic fundamental of the universe itself, and a series of accidents just seem to bring all these things together. And so the bent pyramid. But now let's take this a step further.
Is to really say that, well, here's the kicker with the geometry of it. So as you can see, I haven't changed the compass settings. I will change the color just so it stands out. Okay, so we have a 5-sided object now. Again, we're going to using the basics of Vesica geometry. So you see it's the same setting. Might be a bit. Okay, now you can see that circle. Now we go on this edge, and we draw the same circle. Now what we have here, from there we have an equilateral triangle. Now if I intersect, now I'm going to draw now this circle I'm drawing now is the most important one, because now I don't need to, now all I need to do is mark where they intersect. I mark again, and what we have is a hexagon, a 6-sided shape, and what's better about it is that the edge length of this hexagon is equal to the edge length of that pentagon, which brings up some other beautiful coincidences between geometry. You can even think about chemistry, the way that molecules tend to form in either pentagons and hexagons. Nature just loves these shapes, beehives and pentagons, flowers with 5 petals pointing to the golden ratio as well. As you can see, we're forming a hexagon. Now it's very easy to find the center of that hexagon because this point here defines it. That's one of the beauties of the hexagon. The edge length of the hexagon is equal to the radius of the enclosing circle. So there we have the center of our hexagon. A hexagon is made up of 6 equilateral triangles. As I pointed out earlier, 1, 2 and 3 makes an equilateral triangle. It wasn't even actually necessary to draw this hexagon, I just wanted to illustrate the point, because with this equilateral triangle there, adjust the ruler. Okay, so with that, which brings us back to the bent pyramid. The top half of the bent pyramid, if you unfold it, gives us this pink triangle, which forms the pentagon. If you unfold the red pyramid to the ground, which is but the bent pyramid. This is the top section unfolded, and this is the bottom section unfolded. So a hexagon and the pentagon. This is the geometry, brings us back to the phi ratio. And why is pi important? Well, that connects to, so Great Pyramid model, this pi and phi are in there, and here we have a 5-sided pentagon and a 6-sided hexagon. This 6 to 5, 5 to 6 ratio is really important. It could go on quite a long time about that.
So we have the pentagon or the pentagram, and we have the hexagon, and how the pink and the yellow triangle here fits together. But the hexagon is, well, very lovely, very beautiful in nature. So for instance, of a beehive, but the hexagon is the most efficient use. Structurally it's strong, it's the most efficient use of space. That's why beehives use it, but it's also stackable. It's unique in geometry that way. The inside, so if you go around the edge, the inside angle of a hexagon is 120, the outside is 240. This again, very special, very unique in geometry. But this hexagon, as we see drawing the seed of life, also connects us to the pentagon. Now, previous episode I repeated the animation, but how 4 pentagons around the outside, if we fold them up, what we get is the pyramid, which describes the top section of the bent pyramid, which is exactly the same as the red pyramid. But put again, link in description. This is from Scott Onstott's Secret in Plain Sight, must see video. But here we get an idea of how the hexagon and the pentagon work together. The bottom portion of the bent pyramid derives from the hexagon. The top portion derives from a pentagon. And we'll again, just so we can see it, how this works. So now, instead of the 4 pentagons around the base, now we have 4 hexagons, and a hexagon is made up of 6 equilateral triangles. Equilateral triangles, very important. So again, exactly the same thing as the red section which we drew, which comes from the beautiful pentagon shape. If we fold these equilateral triangles up, what we do is we form the angle which creates the base section of the bent pyramid. Now, there are various explanations to say why it was bent. I think here clearly the geometry explains why it was made, because by folding 4 equilateral triangles up, what we do is we create an or the top half of an octahedron. And again, what do we see there? So that's an octahedron. If we view it in perspective, we even get this, the Star of David, this 6-pointed star shape that most people should be familiar with. It's an interesting that, viewed a 3D object viewed in 2 dimensions creates the cube or the 6-pointed star. And if we overlay the octahedron to the bent pyramid there, and what do we get? Again, it's describing an octahedron. Now there's a lot, that's one of the 5 Platonic solids. Very, very important in nature, in geometry. It's not just a curiosity, it's one of the fundamental truths of the cosmos, so to speak. And so there we see the importance of it. Now that's only one of the Platonic solids, but out of the bent pyramid we get the descriptions of all 5 Platonic solids, and I'll go into that in the next episode. But as a beginning of a demonstration, we see the flower of life, or the seed of life, which can be found in the Osiron, for instance. This was, again, an ancient Egyptians knew about this geometry. They put it in some of their more important temples. The octahedron, equilateral triangles, the pentagon, and so much in regards to Platonic solids. Okay, I'll put some links in the description. Here we see the 5 Platonic solids, and the links in the description will be how to draw them on a 2-dimensional sheet of paper, and then create these 3-dimensional geometric shapes. Now the Platonic solids are special. There's only 5 of them, because what we have is that each side of the Platonic solid is the same shape. So the cube is 6 squares, the octahedron, icosahedron and tetrahedron are all made up of equilateral triangles. That's the shape that defines the base of the bent pyramid. And the dodecahedron is the 12-sided, 12-faced Platonic solid that's made up of pentagrams. And as we saw, the top part of the bent pyramid is derived from the pentagon, not the pentagram. So the square, which is the base of the pyramid, the equilateral triangles, which forms the bottom section of the bent pyramid, and the pentagon, which pentagon, which forms the dodecahedron from the top part of the bent pyramid. So the bent pyramid, it's about hexagons, it's about pentagons, and of course it has a square base. So with the square, the equilateral triangle, which forms the wedge, the 6 equilateral triangles make up the hexagon. The triangle, 5 of those to make up the pentagon. We get all the shapes needed to create the Platonic solids: the square, the pentagon, the equilateral triangle. The explanations again given is that it was they're worried about a collapse, that's why they changed the angle, or the pharaoh died, they wanted to finish it quicker. That's why, that's the reason for the change in angle. Again, extraordinary coincidence that these angles just happen to create this so important 2-dimensional and 3-dimensional geometry. And with that, hope you have a good one. Hello, this will be part 4 in the series Sacred Geometry of the Great to the Bent Pyramid. We've already looked at Khafre's pyramid, the Pyramid of Khufu, otherwise called the Great Pyramid, the Red Pyramid, and the Bent Pyramid. In this episode I'll be reviewing them, elaborating more on the connections between them, but also be talking towards the end about the third of the pyramids of the Giza Plateau, and that's Menkaura's pyramid, and show how they connect as well. It's a part of a series. The builders, the designers of these pyramids clearly had an intent in mind, and they wrote this in a very specific language, and that being the universal language of geometry and mathematics. With that, hope you enjoy. More to come. So here we see a Google Earth screenshot, and just to get an idea of where we are. So we have the Bent Pyramid and the Red Pyramid at Dashur, and off in the distance there we see the 3 pyramids on the Giza Plateau, which are, iconic, enigmatic as well. And so we just have there, and just to give you an idea, and now we'll be using this as a base. So we have the Bent Pyramid, the Red Pyramid, and the 3 Giza pyramids, the Great Pyramids. Just to be sure, Khufu is the Great Pyramid, as it is called. very often Khafre's pyramid, because it appears to be larger, and because the casing stones are still intact on the top, it often gets confused with the Great Pyramid. No, that Khufu's pyramid, or Cheops as it's called, is the Great Pyramid. Now I'm using these names because that's on, if you look it up, that's what they're called. Now there is some, I won't go into the dating, I won't go into who actually built them. That's a very controversial and a whole other topic. So I just want to deal with the geometry, the measurements, and these type of connections. And well, they are all connected. And so this is a compilation of other research, including my own, and I don't think anyone's brought all these pyramids together in such a way before. But first we begin the importance of geometry and the eye there. Now, again, that's a whole political thing. If you show this image, immediately, people launch into all sorts of tirades or whatever. I think that's very unfortunate. It's a deep misunderstanding of the origin of these symbols and the importance of them. For instance, the square goes back to ancient Egypt. It's an important tool in construction, architecture, and, well, of course, so are the compasses. Geometry, measurement, proportion, these are at the essence of construction. And these pyramids, they're monumental constructions. And so please do think of it that way. This is not a political thing at all. Unfortunately, it just gets blended in there together with a whole bunch of internet non-research out there kooky stuff, but that's something else. Okay, so we begin with the basic construction of what's termed sacred geometry, and that's the Vesica Pisces, which is just two circles, same size, the center of the second circle on the edge of the first. This construction is full of excellent, beautiful, wonderful mathematical, geometrical, musical knowledge as well, and also astronomical knowledge too. So we have the Quadrivium, arithmetic, geometry, music, and astronomy. But this construction also will begin a series of links between all of the three pyramids of Giza, as well as the red and the bent pyramid. And to begin with, the Vesica itself is at a 3:2 ratio. To begin with Khafre's pyramid, the middle of the three of the Giza pyramids, that's at a ratio of width to height of 2:3. And, well, the red pyramid and Khufu's, or the Great Pyramid, is also at a ratio of, well, 3:2. So, for instance, the base length of the red pyramid are often attributed to Sneferu, but again, I don't want to go into that. That's something else. But that's at a 3:2 ratio. So the width is 3 compared to the height of the Great Pyramid, 2. So 420 over 280 Egyptian royal cubits. It's the standard of the standard measurement used back then, and we'll be using. So back to the Vesica and these connections. Now, so we have Khafre's, the Great Pyramid, Khufu's pyramid, and the Red Pyramid also already connected by these. Now, the Vesica itself is a wonderful construction because it also is the easiest, best way of constructing an equilateral triangle. So we have it there inside the Vesica, but also we have it there as well. So now we see an example of tessellation, how beginning with the Vesica, if we were to keep drawing these circles and creating what's called the seed of life and the flower of life, we just have a series of equilateral triangles which will expand into a hexagon, but the equilateral triangle is at the core of the hexagon, and therefore everything else which emerges from the flower of life, but also the proportion between them. So if the edge length of the white equilateral triangle is 1, then the edge length of the red equilateral triangle is the square root of 3, which again, just another example of a square root of 3, just a beautiful series of connections. We'll go into that more as we move along. But so the bent pyramid as well, it was the reasons given to explain why they changed the angles don't really hold up. And for instance, now one of the excuses is that
they couldn't support the weight, and so they changed the angle. There was a recent survey, an excellent series called Time Scanners, used the best modern 3D imaging technology, and they found that the lower slope of the bent pyramid is actually bent inwards. Now, if it was changed because of a collapse, they couldn't support the weight, it would be bowed outwards. So that just doesn't hold up. The second reason was, the second most often referred to reason for the change in the angle, was that the pharaoh had died and they rushed to complete it. Well, they just happened to do so at this perfect series of angles, not just the base bringing us an equilateral triangle, 4 equilateral triangles folded in describe the bent pyramid. The top section also is described by a pentagon. So we have a 6-sided figure and a 5-sided figure. Again, an extraordinary symphony of coincidence throughout all of these pyramids, and I say that satirically because it just doesn't, in probability, it just doesn't hold up. These were planned, they were amazing constructions. The units of measurement, proportion, just all tell a completely different story to the official narrative. It's so important to protect the historical narrative, and again, that's just a shame, but we're not being speculative on or using highly text or something, or the story, reading the ancient texts is very much up to interpretation. Geometry, mathematics, astronomy, and musical proportions are not up to interpretation, and we keep drawing a connection between. We'll see that these indeed hold profound knowledge, and so the 3:2 ratio, Khafre's pyramid, that also will create the 3-4-5 Pythagorean triplet, the first of the Pythagorean triplets. 3-4-5 triangle, a squared plus b squared equals c squared, makes this a very important triangle. Now, that same triangle can also be found inside the upper chamber, or what's called the king's chamber, and we see there the 3-4-5 triangle. The king's chamber itself is a microcosm of the Great Pyramid. So we have a microcosm, macrocosm, 6s and 5s as well. That's an important feature. Again, connects all of these pyramids together. And it could be called a coincidence, but the more coincidences you draw together, you have to get rid of that. You have to throw it out the door. It's time for this to end. The Egyptian rope stretchers famously used a 3-4-5 triangle as well. Again, the official story will be, well, they knew about the 3-4-5 triangle creating a right angle, but they didn't understand Pythagorean theorem. Well, okay. A squared plus b squared equals c squared. This is Pythagorean theorem is said to have been invented or properly understood by the Greeks. And well, that also applies to musical theory. So Pythagorean hammers, the perfect fifth is this 3:2 ratio as well. So musically speaking, the pyramid of Khafre and the Red Pyramid and or Khufu's, or the Great Pyramid, also just all seem to come together at this rather lovely series of coincidence. The Delian Problem is another wonderful example of the extraordinary symphony of geometrical and arithmetic and all this other knowledge encoded inside the pyramids. Now, the sarcophagus inside the upper chamber / king's chamber, well, the internal volume is half of the external volume. This is the Delian Problem, is, well, doubling the cube, doubling the volume of the cube, and we see that expressed here inside the pyramid. Again, the normal history will tell you that it was solved many thousands of years after, during the Greek era, during the time of Plato. However, we see examples of it being embedded inside, well, the Great Pyramid. So the cubed root of 2, 1.2599210, etc., on and on we go. Now the compass and square, why do I have that there? Well, because that in itself encodes the square root of 2 using Pythagorean theorem. A squared plus b squared equals c squared, so 1 squared plus 2 squared equals 2, and therefore the root of 2 is expressed there in the 45, 90 degree square. However, that will also bring us to a really beautiful close approximation of that in the bent pyramid, and shout out to Space Creator Band. He posted this in a comment on a previous video, and he points out that the angles of the bent pyramid themselves form a very, very close approximation of the Delian problem, or the cubed root of 2, as we see here. Now, that's based on the best available measures. The fact is, just like the Great Pyramid, the pyramids are not built exactly the same on each side, and I think with more detailed survey data, we'd probably find, and I'll be willing to bet, that one of the sides will actually deliver us to a even closer. So we're already talking about 0.0017 difference. So again, we're splitting hairs in regards to this. If you could achieve that level of accuracy in any construction, you'd be doing really, really well. However, just like with the Great Pyramid, the slight variations on each side point to a beautiful series of knowledge, in that each side has a different meaning to them. So for instance, one side is astronomical knowledge, one corner. The other corner is in regards to proportion of phi and pi. One corner is phi and pi as measurement in meters, and we'll talk about meters shortly. And another corner has some extraordinary geometrical knowledge, both in the second and the third dimension. However, it does extend further. Okay, so the red pyramid showed in animations how we have a series of pentagons, and that if we fold those up, so if we fold up those red triangles, what we get is this pyramid, and that 43.22 degree slope angle describes both the bent pyramid and the red pyramid. So the top section of the bent pyramid is it's a pentagon, and the red pyramid itself is a pentagon. And now if we go back, the bent pyramid has that equilateral triangle angle, so that would create a hexagon. 6 of these creates a hexagon, and the pentagon, 6s and 5s, very important. The pentagon and hexagon, even if you think the way in chemistry, the way that molecules will form, they're in pentagons or hexagons. It's just built into nature. Nature demands these things. And so the red and the bent pyramid are connected by the pentagon. However, that will also bring us to the Great Pyramid as well. And so, for instance, we see a pentagon, the angles are there, and I'll give you a better example. We'll see it in a larger size. And so the pentagon itself and the pentagram inside it is perfectly proportioned to the golden number, the divine proportion as it's called, phi. Even the angles in trigonometry bring us to beautiful knowledge in regards to that way. Now you could also consider the 72 degree angle. 72 years is 1 degree of precession. 72 degrees is 4,320 minutes, and that would equal, in seconds of the compass, 259,200 seconds, which is 25,920 years is the precessional cycle, so just 1/10. Just extraordinary connection. Even 108.36. All the angles of the pentagon are just beautiful. However, the proportions of this construction themselves bring us to the golden number, which will connect us to the Great Pyramid, because, as one example, the slope length to the half base is at a ratio of 1:5, a golden number. I've done other videos on that. I've gone into some detail. Each side of the pyramid has a slight variation on it, and so the idealized measures will give us 1.618181818, but that's the idealized measures. The pyramid itself is not actually exactly to that measurement. Each side has a slight variation, and that's an important consideration, but not just in proportion, also in units of measurement, specifically the meter, the Great Pyramid has multiple references to the golden number. Again, I've covered that in earlier videos and I'll put links in the description. But what we see is through the pentagon and pentagram and through the golden number, the bent, the red, and the Great Pyramid are connected. In regards to the meter, a 1 meter pendulum swung will create a 1 second frequency. So if you could test it at home, get a piece of string as light as you can, put a weight on the end, and from the center of gravity, 1 meter long, and swung at 30 degrees, which is an important in regards to geometry, even the position of the Great Pyramid. Well, that 30-degree swing, the arc length is 1 Egyptian royal cubit within splitting hairs again, but also will bring us to the 86,400 seconds per day. If you were to stand at the northeast corner of the Great Pyramid, multiply the maximum visible base times 86,400, you get the circumference of the Earth. You have to include the sockets. If you include the paving stones or socle, multiply the height of the Great Pyramid by 86,400, you get the polar diameter of the Earth. Very often you'll see the number 43,200 used. I'll put a link to that video as well. Well, that only describes half of the Earth, and it requires 2 views. It's rather inelegant in that way. Still, pretty nice. It's very good. However, if we consider the connections between the Egyptian royal cubit, the 1 meter connections, which will give us pi and phi, Fibonacci, and all these other connections connected into the Great Pyramid itself, they're all exquisitely joined. But I've done that in earlier videos. However, this is an important consideration, the Egyptian royal cubit, because it's through the meter, we get a description of 1 second, the time, but also it's a unit of measurement. So the royal cubit, the meter, and the second are all exquisitely connected. But that will all, through understanding this and moving away from the 43,200 and understanding it in this particular way, we can also show another connection, because the height of the bent pyramid is 200 Egyptian royal cubits, the height of the red pyramid is 200 Egyptian royal cubits, and the width of Menkaure pyramid is 200 Egyptian royal cubits. Now it's important to note that Menkaure's pyramid is slightly rectangular, and this in itself, this apparent error, actually contains profound information as well, and I'll get to that in the future. But the base length on one of the sides is 200 Egyptian royal cubits. The other base, if you move around to the other side, is slightly more than that. But that in itself is not an error, and it contains profound information. And again, I'll cover that in the future. But what we have is the geometry of measurement, proportion, angles, and time coming together to bring these pyramids together in a very exquisite, profound, important way. Okay, so that's it for this part. But again, we start to see the extended connections, how they're connected exquisitely through geometry, measurement, proportion, angle, and time. Hermeticism. Hermes, the god of weights and measures, trade and commerce. Thoth, the god of weights and measures. Also the god of engineering, who is connected to the construction of these awesome, amazing, beautiful, ancient pointers to this ancient system of knowledge, and this knowledge embedded through, well, the gods of knowledge, of gods of weights and measures, Hermes and Thoth. With that, hope you enjoyed and have a good one. So let's look at beginning with the Giza pyramid. So on the left, the Great Pyramid. In the middle we have Khafre's pyramid, and how sacred geometry connects these. But we'll also be looking at the Red Pyramid as well. I'll put in the link in the description to the previous upload where I was looking at one way to draw the Great Pyramid. But Khafre's pyramid, here we see. So often you'll see this called the Great Pyramid because it still has those casing stones at the top,
but that's how you can tell Khafre's pyramid from the Great Pyramid. And here, not too far away, we have the Red Pyramid. Now, these are all connected through the principles of sacred geometry, especially the Vesica Pisces. So to begin, we're going to draw the Vesica Pisces, or the Vesica Piscis vessel of the fish. It's always best to begin with a construction line, and again, this is compass and straight edge geometry. I used a marked ruler, but you're not supposed to use the marking, so a ruler counts as a straight edge in that case. So to draw the Vesica, it's one circle, and then we'll draw a second circle without changing the compass setting, and the center of the second circle is on the edge of the first, and this is the basic unit of our construction in sacred geometry.
And so now we have, so if the radius, the compass setting is 1, 1, 2, 1, 2, 3. And now without changing our compass setting, so I always start with a construction line. That helps a lot. And now we're going to draw a line there, which would be at 90 degrees, and this is just another reason why it's very cool construction, because as a basic building block for all other types of geometry. Now we're going to we haven't changed the compass setting. Now I'm going to put it on the center of these two lines. Mark it, do the same on the bottom. Now on the edge, and do this on both sides. It's more on this side. Small section of arc. Now we need to change the compass setting so from the center. And then we use that point there, mark, while we're here, do that side as well, again, and now we can draw a rectangle, and we know, because that's 1, 2, 3, 1, 2, that it's 2 to 3 rectangle, which is very important in music theory, especially in the Pythagorean schools. Okay, it was a rough little bit, that should be accurate, but you get the picture. Okay, so what we now have is a rectangle that's 3 wide, 1, 2, 1, 3, and it's 2 high. Now that of course will connect to Pythagorean theorem.
Now we can compare the Red Pyramid with the Great Pyramid using that Vesica construction, which is at a 2 to 3 ratio. And the Red Pyramid's also very interesting because of the pyramidion that was found there, exactly 1 meter high, until it was essentially vandalized under the care of Zoe Hawass. But however, so the Great Pyramid at 280 royal cubits high, the Red Pyramid is 420 Egyptian royal cubits wide at the base, and so here we see it's a 3 to 2 ratio. So the Vesica once again, and this all important 2 to 3 ratio, which has so many other applications, joins the Red Pyramid and the Great Pyramid through sacred geometry. This all important 2 to 3 ratio can also be used to connect Khafre's pyramid and the Great Pyramid. They stand together. Khafre's pyramid, that one there in the middle, still has the casing stones there at the top. All too often I see this described as the Great Pyramid because it appears to be taller, and well, because the casing stones are still there for whatever reason, but that's Khafre's pyramid, not
Sites
the
around
Great
the
Pyramid.
world. But music theory, very important. But the key part is what we now have is if, so I'm going to do a diagonal from here to here. Same thing from the bottom corner to the top there. Okay, so I'm just going to freehand now, and so now we have two triangles. Now since it's free, okay, now let's just sort of redefine that for a moment just to get the proportion. So if this is now free, this now becomes 4. So we have 3, 4. Pythagorean theorem, a squared plus b squared equals c squared. So that would be 4 squared is 16, 3 squared is 9, therefore this would be 25, and that would be 5. So we have a 3, 4, 5 triangle.
So this 2 to 3 ratio describes Khafre's pyramid, as well as lovely connection there to the 3, 4, 5 triangle, which is also important in masonry, as we saw earlier. Even the Vesica is a standard symbol amongst the esoteric world. But the 3, 4, 5 rope stretches was an ancient Egyptian method of measuring land. But we also see it in the Great Pyramid itself, in the King's Chamber. I'll put a link in there in the description. Recently did one on the Delian Problem, how that's also built into the sarcophagus in there. So this very simple geometry, this very simple construction, the Vesica, the 3 to 2 ratio, not only connects the Great Pyramid with the Red Pyramid at, again, this 3 to 2 ratio, but it also joins Khafre's pyramid with the Great Pyramid. What's as above, so below. What's on the inside is what's on the outside. So these are joined, but of course it will also connect to Pythagorean schools, which is so important in regards to esoteric, and but also, so for instance, music theory, the Pythagorean hammers at the 2 to 3 ratio being the perfect fifth. It goes like this, the fourth, the fifth. But also on Pythagorean or scientific tuning, where C256, A432, but these are all at 3 to 2, 2 to 3 ratios. Very important. Another consistent theme is also the Limestone, which describes the ancient conversion tool, which includes a modern English foot. That's at a 2 to 3 ratio, which incorporates Doric and Ionic and Samian as well. And just like the Pyramidian cap at the Red Pyramid, which is 1 meter high, it's just like the Limestone. It's a conversion tool which incorporates proportion and measurement. It's such a lovely system. And from the Vesica Pisces, the Vesica Piscis, the vessel of the fish, in this case I've drawn it vertically instead of horizontally, but you'll find that in Christian symbolism, Rosicrucians and others, there we see a double Vesica Pisces, an extra circle on there. Sun, Earth and Moon knowledge is built into this. It's just an awesome method. And of course, for instance, that's a glass, that's the window from the old Masonic Hall here in Newcastle in Australia with the Vesica, but also of course the 3, 4, 5 triangle being so important in the engineering tradition as well as the modern system of ritual. So geometry, compass and straight edge geometry, it's quite ancient. It describes, well, the Great Pyramids, the Great Pyramid itself, as well as of course Khafre's pyramid and the Red Pyramid. And from this simple geometry we can also extend it. I'll do that in the next few episodes. But it will also join us to the Bent Pyramid as well. And here in this picture we can see the Red Pyramid in relation to the Bent Pyramid, and if it wasn't probably a haze, you could see the Khafre and Great Pyramid off in the distance. There's the Bent Pyramid. It's, again, that would be a lot to talk about in another episode, but whether this was an accident or not, that there's some evidence to say that it wasn't. But what we have is, if you unfold each portion, we get both a pentagon and a hexagon, 6s and 5s, and this 6/5 ratio, both in systems of measurement but also the construction of these in geometry, are core both in Euclidean or sacred geometry. And so compass and square, sacred geometry, the pyramids, which will also connect to so many other ancient sites across the world, but it really is a thing very interesting. And with that, I hope you enjoyed and have a good one. Hello and welcome to part 5 in this series, Sacred Geometry of the Great to the Bent Pyramid. And in this particular episode, we'll be focusing on this pyramid down here, the Meidum Pyramid. Pardon the pronunciation, there's a few variations going around, but we have the Great Pyramid, Khafre's and Menkaure Pyramid, Red Pyramid and Bent Pyramid, which previous episodes covered those, but we'll be now looking at this one further down to the south. It's unlike the other pyramids, the ones we covered, which were built in a very different way, essentially stacked up on top of each other, interlocking blocks, very well engineered. The Meidum Pyramid has collapsed, again, because it was, we see the internal structure, and then it was encased on the outside. It was bound to happen. There are some really crazy theories going out there, but the smooth structure, it wasn't interlocked. You build something on the outside without connecting it in. The sand foundation, this was, it was not nuclear bombs. But this is one of the reasons for the collapse. However, and we'll look at that just to get some idea of the remaining structure. But there is enough of the base still surviving because of it wasn't slim, and there's enough surviving so we can get some information out of it. And just as a cross section, you can see like these slimmer sections. Again, it was essentially bound to fail. It was also constructed in a very different way to the major pyramids, such as those on the Giza plateau or the Red and the Bent Pyramid. You can see the internal structures of them, how they were built, very, very different. Again, just so much of this area, especially on YouTube, get a lot of, quite frankly, outlandish claims, clickbait. But the pyramid itself is very important, some very beautiful geometry, astronomy, arithmetic built into it. So we're going to be connecting it especially to the Great Pyramid, otherwise known as Cheops Pyramid or Khufu's Pyramid. And we were working especially off the work of Matthew Flinders Petrie, basically the father of modern archaeology. He was a master surveyor, including Stonehenge and the pyramid itself. So the first very, very accurate, very detailed survey of the Great Pyramid, and so much of Egypt was undertaken by Matthew Flinders Petrie, where for various reasons, for instance, the amount of rubble or buried in sand, earlier archaeologists weren't able to take measures, and then we had other people come along, Perring and Weiss, and they were, okay, I'll leave that to the side. But also important feature, because Matthew Flinders Petrie in this particular era was about establishing the Egyptian royal cubit, and this will be the measure we'll be using. So for instance, the Great Pyramid, the idealized measures are the base 440 Egyptian royal cubits with a height of 280 Egyptian royal cubits. Why I put the asterisk there is because both the Petrie survey, the J.H. Cole survey, Egyptian government survey, and even later the most modern surveys show that the pyramid itself has variations on each side. And so I'm using the J.H. Cole. He was pretty much widely considered the best. All later surveys have shown, within above 99.9% within acceptable margins of error in measurement. And just as important to note, so 755, 756.84 or 072, the western side 755 feet at 0.772, and the slight variation. So just as an important point, now it's often said that the pyramid base is 756 feet. exactly? Well, no, it's not. There has been no survey to show this. There is a slight variations on each side, and these are in fact very, very important in understanding some of the more beautiful, deeper meanings of there. Brings in this series of extraordinary coincidence in regards to arithmetic, geometry, astronomy, and music, the Quadrivium. Or the focus being geometry. I'll put the links in the description to the survey and the work of Petri. Especially Petri's work talked about some of the interesting details in regards to the construction and some unexplained, as yet unexplained elements in regards to that. Now there is still a question mark over that, but some very interesting questions still yet to be answered. So the Great Pyramid, 440 over 280 Egyptian royal cubits, that's a 7:11 ratio. In 1859, John Taylor was first published to propose that the Great Pyramid encodes both pi and phi, the golden ratio, or the divine proportion was included in the pyramids. Now again, later surveys have shown that he was onto something. And so, for instance, this is like a cross-section of the Great Pyramid, and the 7:11 ratio, 11 wide, 7 high, creates very, very good approximations of pi and phi. Not exactly, but very good approximations. However, if you use the actual survey data rather than round off the measures, what you'll find is that these slight difference between super accurate phi, super accurate pi can be resolved. I'll put a link in the description where I explain like each side of the pyramid has a slightly different measurement. Therefore, the discrepancies, the differences between phi and pi, and some very important geometric knowledge such as the area of a circle inside a square, the area of a cube of a sphere inside a cube, squaring the circle, can all be resolved to a very high level of accuracy. You have to use the actual measurements rather than idealized, rounded off ones, and you have to consider that each corner, each side has a slightly different measure, and as we move around the pyramid it actually tells a wonderful story. I'll put the link to that and a couple other related videos in the description. So the 11:7 ratio. Now Petri also surveyed the Meidum pyramid, and it also has a 7:11 ratio, so it's 275 Egyptian royal cubits at the base and 175 Egyptian royal cubits in height. Now, of course, how did he measure the height? Well, we use the angle and like the remaining angle to give us the slope angle. Therefore, we can work out the height. That's exactly the same as in regards to the Great Pyramid. So when all the surveys were done, that the top levels had been removed, but through the casing stones and the angle of the pyramids were able to work out it was a 7:11 ratio, and so was this pyramid, and therefore we start to get an extraordinary. This pyramid contains the same beautiful connections of the Great Pyramid, but even they relate to each other in a very beautiful way, especially in regards to the golden ratio through the Fibonacci sequence. So both the Meidum pyramid, the Great Pyramid, has the 7:11 ratio, pi, phi, very, very close approximates. Again, use the actual measurements and as you move across, but that's... So, well, to begin with, both these pyramids share a beautiful geometry, and that will connect. So, 11 wide, 7 high, 11 over 7 is a very, very good approximate of phi. In real-world engineering conditions, 22 over 7 is, as you know, if you can reach that level of accuracy in your constructions, you're doing really, really, really well in the real world. Paper theory is one thing, but actual construction, that's something else. And 7:11 is a more than adequate description of pi. So, but that is half pi looking at the cross section. What we need to do with all these pyramids is consider that they are three-dimensional objects and look at them in a three-dimensional way. And so, for instance, if you stand at the corner of the Great Pyramid, what you get is a 22 over 7 ratio. Now, in the video I mentioned, because of the variations on each side, we actually get a much more accurate, or not, well, that's very close, but the
pi ratio is even closer, because the pyramid itself is not exactly the same base length on all four sides. But of course these two, so the Great Pyramid, 280 Egyptian royal cubits high, 440 Egyptian royal cubits wide. The Modern Pyramid, 175 Egyptian royal cubits high, 275 wide. That's a ratio of 1.6 to 1, or 8/5. 8 and 5 are Fibonacci numbers, and here we get this phi spiral from the Fibonacci numbers.
So just to correct, the slope angle of the pyramid is 1.61859 using this ideal 7 to 11 ratio. However, if you spreadsheet the Fibonacci numbers, there are some deeper connections, and I'm going to be revisiting this again later, so just a correction there.
Very good, very, very close descriptions of pi, very, very close descriptions of phi. Of course, if you use actual measurements and spreadsheet that, you'll get it's much, much closer than that. So we also have ancient geometric problems, over 4 problems of antiquity: doubling the cube, angle trisection, and squaring a circle. Mentioned previous episode, both the bent pyramid, the ratio between them. I forgot to mention, so we have 6s and 5s in the bent pyramid. Well, the Great Pyramid, the total height including the subterranean, is at a ratio of 6 to 5 to the portion of the pyramid above. But the bent pyramid, we have the Delian Problem being solved and the sarcophagus inside the upper chamber or king's chamber. We have the internal volume is 1/2 of the external volume, again above 99 or even high 99.95% accuracy. Again, if you can achieve that in real world conditions, you're doing really well. And so that's the first of the 4 problems of antiquity, has been the geometric connections between all of the pyramids rather than just focusing on the one. However, squaring a circle, that's of these ancient problems, that's the third. And 7 to 11 ratio, draw a square around the base, so the base of the pyramid forms this square. If we then use the height of the pyramid, fold that up, we get this diagram, and that is squaring a circle above 99.9% accuracy. And we also have phi and pi above 99.9% accuracy, but again, if you actually use include the slight variations on each side, what you get is even higher accuracy than this. This alone is amazing. To achieve this is very, quite sophisticated, but to do it, they've actually achieved it at higher levels of accuracy, especially in the Great Pyramid, if you include the actual measurements rather than rounding them off, as unfortunately is the tendency. What else does this incorporate? Well, it's the relative size of the moon to the Earth is also embedded in this extraordinary, lovely geometry. So 3 to 11, again above 99.9% accuracy. And again, if you include the actual measures and variations on each side, you'll find that it's even closer at 27.3%. Again, extraordinary symphony of coincidence. All of the pyramids, the major pyramids, now there are hundreds of smaller pyramids, but I'm talking about the monumental structures, which were again monumental efforts, huge efforts to construct these. We can just draw the same geometric, mathematical, astronomical, and musical connections, and we're telling a story of maths and geometry, which official history would credit to the Pythagorean Platonic era. But again, to call this a coincidence is just insane, and it's just unfortunate that the Egyptian establishment, best represented by Zoe Hawass, will scream and scream and dismiss this and sort of throw all sorts of names. Again, just we have one extreme where we have really outlandish claims made, and well, unfortunately, the gatekeepers of the Egyptian establishment, not all of them, and that must be focused, not all of them, there are many, many good people working. There is a small collection of high-ranking Egyptologists which protect their narrative and protect their textbook sales at all costs, and they're two extremes, and we need to examine the data and look at it. with fresh eyes, and we can measure this. This is tangible, it's testable, it's verifiable, doesn't rely on interpretation, and unfortunately this has become the official narrative exemplified by Zoe Hawass. Has infiltrated. Again, it's just a shame. And what we see is a beautiful connection which draws together so many ancient places across the world, from the stone circles in the British Isles, places such as Karnak, again across the world, across the ancient times, across time, across cultures. But with that, hope you enjoyed and have a good one.
Okay, so I hope you enjoyed this. I hope you learned something. Please like, share, comment as you wish. I will be also updating some older versions in regard to the pyramid, the meter, pi, phi, and these other constants. With that, have a good one.